vectors. And if you've taken physics or you're in physics, no, they're not exactly the same. There might be some things that you find similar, but we do things a little bit different with how we, well, actually, it's a lot different. So if you didn't like them, you might like these better. If you liked them, this might not be your favorite. I will give you the honest truth. I thought I printed off the notes and had keys already made for them. And then I went to go do them here a little bit ago and figured out my notes are not the same as what I thought they were. And so I am doing this from last year's memory. So I'm definitely breaking it up into 3 chunks this time, just so I can kind of refresh myself every time I go through here. Okay? So vectors. A vector is just a line segment, but it has magnitude and direction. And magnitude's like the size of it. We're actually going to use something that looks a lot like the distance formula. Actually, that's what it is. It's the distance formula. Each vector has an initial point, so a starting point, and an ending point, which is called the terminal. So starting, ending. PQ is the line segment that you're used to making, but you usually use lowercase bold letters to do that. Now, you can't tell if I'm making them bold when I write them, so just bear with me. Okay, so vectors are denoted using the little line symbol. A vector PQ above can be named PQ, or vector P, or with a lowercase p, or it can be lowercase v, like doesn't really matter, okay? So let's talk about magnitude. I told you and said it's basically the distance formula, and that's exactly what it is. It's the distance formula. Okay, I don't think you remember it, and that's okay. So it uses this double bar V symbol, so these double bars. It does not mean you're taking the absolute value twice. And to find it, you would take the difference of things. So you take y2 minus y1 and you square it, and x2 minus x1 and you square it, and then you get your answer. Another way it can be written is a squared plus b squared. So just keep that in mind that there are other ways to write it, depending if I give you like a coordinate point. So this is if I give you 1 coordinate point, and this is if I give you 2. So, well, I don't know, I'd put coordinate after point, but that's fine. So that's if I gave you like a point A, B. I really could write it as x, y, but it's okay, whatever. All right, so if I want to find the magnitude of this vector, all right, so you're going to take the difference of the y's and the difference of the x's and square them. So -2 minus -4, okay? -2 minus -4 is the same thing as adding 4, and we square it. And then we're taking -7 minus 8, and we're squaring that. And I'm going to use my graphing calculator because I want to make sure I get all the math right. So we get the square root of 2 squared, and we get -15 squared. So that gives us 4, and 15 squared is 225. So if we added that together, you really get the square root of 229. And this time around, I'm going to actually simplify it just to work on that. We're going to see if we can simplify 229. I don't think we can. So 229 divided by 3. Nope, 229 divided by 7. 229 divided by, I can't think of anything else. 9? No. So this is your answer. Square root of 229, and we're going to put units at the end of it. All right, so very simple. I'll go through and do this one. You're going to do, and it doesn't matter which order you do. I always do the last and then the first. You can do the first and the second, but whatever you do with the y values, you have to do with the x. So we have -7 minus -5, which is positive, and we square it. We have -1 minus 1, or -6 minus -1, which is positive 1, and we square it. Okay, so that leaves us with -2 squared and -5 squared, all under the square root. And then that gets you 4 plus 25, which is 29. And 29 will not simplify, just going through my numbers like it's not divisible by 3 or anything like that. So that's your answer. All right, just write this definition down. Just pause the video and go ahead and write it. But zero factor is a vector that has a magnitude of 0, so there's no distance on it. And basically it's saying its starting point is where it ends. So that's a zero vector. And then I want to go over the types of vectors. So this should be kind of cut and dry. It's the same or opposite direction. but not necessarily the same magnitude. Just saying that the lines are parallel, okay? Parallel lines. And they could have, let's draw that a little bit better. Different, like this could be like this, but we're going to say they're parallel, okay? They're not going to intersect. Equivalent magnitude have the same exact magnitude and direction, meaning they're set in the same way, and the distance, the length of that line segment is the same. So if we're heading this way, it's also heading this way somewhere. It doesn't have to be in the same location, but it's same length, same direction. And then the last but not least is opposite. So they have the same magnitude, so they're the same length, but they had opposite directions. Okay, so let's kind of talk about what A and negative A. So let's think about this. Like a positive slope would be going this way, but a negative slope would be going this way. So same length, opposite directions, okay? This is the first video. There's going to be 3 of them, page by page, all right? If you have any questions, remember, get a hold of me.